Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, crisps expand on a plane because the air pressure drops. Explain why pressure drops on a plane. So as you go up into the atmosphere, the air actually becomes less dense the higher and higher you go up. So there are fewer particles, or what I should really say is there are less frequent collisions of the air particles because there are fewer of them in a given area. So what does that do? The less frequent collisions reduces the force, and since pressure equals force over area, if you reduce the force, you also reduce the pressure. The second thing, though, is that actually there's less force pushing down in the first instance because there's actually a smaller weight of air on top of you. So not only does the air that you have get thinner, there's also less and less of it on top of you pushing down. So both of those two things contribute to this pressure drop in a plane. Okay, calculate the change in pressure of a person who climbs from sea level to 300 meters above sea level. Air density is 1 kilogram per meter cubed. Compare this to the change in pressure from sea level to 3,000 meters below sea level, and we're given seawater density as well. So fluid pressure, we have that special equation. Pressure is density times G times H. So what is my change in pressure? For the first part of this question, my density is the air density, which was 1, G is 10, and H is 3,000, that change in height. So let me plug that in. My change in pressure is 1 times 10 times 3,000 is 30,000 pascals. Now, what about the second part? Comparing this to the change in pressure when you go from sea level to below sea level. So this time I've got my same equation, but the thing that's changed here is my density of seawater is much, much larger than my density of air, 1030. Pressure is, don't know, gonna find out. Density 1030, and G, always on Earth, 10. H, height change is the same, 3,000. So my change in pressure is 1,030 times 10 times 3,000 is 3,090,000 pascals. So a much, much bigger difference in the change of pressure there. A pupil says the total pressure acting on a person 3,000 meters below sea level is equal to the previous calculation. Suggest what he's forgotten to include. So that was the change in pressure from being at sea level to being 3,000 meters below sea level. But that's not the pressure 3,000 meters below sea level, because that's actually just the pressure due to all that seawater which is above you. You do still have atmospheric pressure acting on you as well, even when you're 3,000 meters below sea level. So you need to add that on if it were asking for the total pressure, 3,000 meters below sea level. A pupil says when an object sinks, it has a smaller upthrust than when an object floats. That's why it can't float. Discuss. Well, let's think about what upthrust is first. So it's the weight of fluid displaced. And in order for something to float, you need to have a balance of the weight of the object and the upthrust. So I have a little look at this picture here. It is not, it's a common misconception, but it is not that things that don't float, it's because they have smaller upthrust than things that do float. Because really, it's the balance between the upthrust and the weight. So you can see in this picture here, on the left-hand side, we have something that's sinking. It's got, that should be a larger downward arrow. I don't know if that's very obvious from the picture. It has got a larger weight than upthrust, but it's still got quite a big upthrust because all of that object has been submerged in the water, and my upthrust is the weight of fluid displaced. So it's displaced the maximum amount of fluid that it could possibly displace by the whole object being submerged. So actually, that object there ends up with a larger upthrust than the object on the right. This is my floating object, and you can see only half of it is below the water. So actually, only half of it is displacing any water, and therefore the upthrust is smaller because it's just the weight of how much water has actually been displaced. But because this one has a smaller weight itself, i.e. the object has a smaller weight, that small upthrust is able to balance that weight. And in the one on the left hand side, the weight is too big, even though the upthrust is also quite big. A pupil says you're more likely to be able to float in a liquid with a smaller density. Discuss. Okay, so this is the idea that we can have a look at whether something's going to float or not by comparing the densities, the density of the object and the density of the fluid that you've put the object in. So if the density of the object is larger than the density of the fluid, it will sink because it can't displace enough of that fluid to have a large enough upthrust to float. So what did the pupil actually say here? You're more likely to be able to float in a liquid with a smaller density. Discuss. No, you want your liquid to have a higher density because it needs to have a higher density than the object, or at least the same density as the object for the object to float.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, a few tips and tricks for this section. Upthrust not larger, the more float. Yes, this one is the one I've been going about this whole video. Just because your upthrust is very big, that doesn't mean you float. It has to be equal to the weight of your object for it to float. And in fact, if the weight of your object is very, very small, you won't displace much liquid and you won't have a very large upthrust, but they'll balance each other. The small weight will balance the small upthrust, and your object is more likely to float. Okay, change in pressure versus atmospheric pressure. Yeah, so when you're doing pressure is rho times g times h, that h is technically the change in height, and therefore will tell you the change in pressure if you move from one height in a fluid to a different height in the fluid. If you then need to know what the total pressure is on an object, if they're at that point in the fluid, you need to first work out the pressure due to the liquid, so due to whatever height of liquid is above it, and then you need to add on atmospheric pressure as well. But you don't need to worry about atmospheric pressure in calculations where you're just looking for a change in pressure. Remember to make 2 points when you're talking about how the pressure due to a fluid, especially like air, atmospheric pressure, changes as you rise up. One being the density of the fluid. So in air, talking about the fact that air gets less dense the higher and higher up you are. And then the other to do with the weight of fluid that is actually still on top of you or not. Pressure arises not equal to upthrust. Why that happens. Yes, so this is the point that you need to say that upthrust is a consequence of the fact that you have, for an object in a fluid, 2 different pressures. A different pressure at the top to the pressure at the bottom. And that's because there's a different amount of liquid pushing down on the top than the amount of liquid or fluid that's pushing down on the bottom. And that difference in pressure between those 2 points is what causes your upthrust. But it is not equal to your upthrust. You can't find that change in pressure and then say that that's equal to upthrust. They're not equivalent. Your upthrust is equal to the weight of fluid displaced, but it's a consequence of the fact that there's a difference in pressure between 2 points on your object.